look at some formulas. So you have a handout with the flip chart on there, and so if you look, the first formula is an equation for exponential growth. Okay? Biggest thing you need to understand, y is your final amount, a is your initial amount, r is your rate as a decimal, and t is your time. Okay, so we know those four things. So let's go ahead and look at an example based on that. It says the prize for a radio station begins with a $100 gift card. Once a day, a name is announced. The person has 15 minutes to call, or the prize increases by 2.5% for the next day. Write an equation to represent the amount of the gift card in dollars after T days with no winners. So let's start. Y is our final amount. That's what we're trying to find. Okay? What is A in this problem, guys? 100, because that's our starting amount. Very good. 1 plus. Now the rate is as a decimal. So when it says 2.5%, I don't put 2.5. I actually put 0.025. I always move that decimal 2 places. And then my exponent will be t, because I don't know how many days it's going to go. The next, what?
What do you do with the minutes?
You don't need to worry about the minutes because it doesn't matter. It just says that they have 15 minutes to call in or they win. So that 15 is kind of extra stuff. You don't need that in the problem. Okay? Now, real quick, one thing that you need to do is you need to go ahead and add 1 plus 0.025. And what will that give me? 1.025 to the t power. And that will be your answer. Now on the next one, it says, how much will the gift card be worth if no one wins after 10 days? So this is what you're going to do. We're going to use what we found in A, and we're going to plug in 10 for what? T. Okay, so yes, you will need a calculator. And so what I'm going to do on my calculator, there's kind of a trick here. What you guys need to do first is this step right here. When you get an answer, you take that times 100. So you two are going to look for your y to the x key. There's a y to the x right above the division sign. And so there are two ways to type this in. If you have one of the Texas Instruments, the basic ones, you're going to do this right here. Okay? Once you get an answer, you'll take that times 100. If you have one of mine, you're going to use the caret key. Okay? There should be a caret key that looks like a little hat, and that's how you're going to do 1.05 to the 10th power. When you get an answer there, you will take it times 100. Okay, so 1.025, hit the y to the x or the caret key, then hit 10, press enter, then take that answer times 100. What did you get?
I got 1.28008454.
$128 and what would it round to? 1 cent. Okay? So biggest thing you've got to do is that power. Okay?
So
You're looking for the, yours is going to be the caret key. Yep, right here. So you're going
that's
to
what
do,
I did.
okay, yeah, now take it times 100.
Oh.
There you go. And there's your $128. Okay, so far so good. Is there anybody that didn't get that? Because we got to make sure, yeah.
I can't find this.
You can't find what? Okay, 1.25, here's the caret. You just do 10. Okay, enter. There's your answer. Take it times 1. Okay, so it's that little caret. Alrighty, so let's go ahead and look at the next one. It says a college's tuition has risen 5% each year since 2000. If the tuition in 2000 was $10,850, write an equation for the amount of tuition T years after 2000. Predict the cost of tuition for this college in 2015. So this is just like the previous problem. I've got two answers. an equation, and then what the tuition is. So let's start with the equation. Y equals, what is my starting amount?
10,850.
10,850. And then 1 plus 0.05, very good, and then to the t power. So what I'm going to do now is I'm going to go ahead and add the 1 plus 0.05, and I get 1.05. First answer is right there. Now the next answer says predict the cost of tuition for this college in 2015. So what am I going to do?
2015 and 15.
Plug what in for T? 15. Why 15 instead of 2015? Let's look what it says. Each year since 2000. Yep, and I've started with 2000. I want to know what happens 15 years from now. Okay, so once again on your calculator, 1.05, hit the caret key and then 15, then take your answer times 10,850. Because that's 2015, between 2000 and 2015. So did we get a big number? Yeah, you should have. What'd you end up getting for your answer?
22,556 and 37 cents.
Somebody else get that?
Yeah. It was 37 cents yours, whereas mine went up to 40.
So that's exponential growth. So those are a few things that grow exponentially. Let's go ahead and look at the next slide. Okay, this next slide is compound interest. So compound interest is like what happens like in a bank. Okay, savings accounts. Even though you don't get very much money for your for savings accounts now. And so real quick, A is the current amount, actually A is going to be your final amount. P is the principal or initial amount. And then notice this formula. It says 1 plus R over N to the NT. N is the number of times the interest is compounded each year. So real quick, let's talk about that. Okay, for N, if it's quarterly, how many times does that mean per year? 4. Let's think about quarter. A quarter, there are 4 quarters in a dollar. Okay, let's think about monthly. What would monthly be? 12. Okay. Annually is just going to be once. So those are just kind of a few of the numbers that can kind of help you. So let's go ahead and look at an example. Maria's parents invested $14,000 at 6% per year compounded monthly. How much money will there be in the account after 10 years? Okay. So let's go ahead and start. So we have A, that's how much we want to know. P is what? Yep, so what was it in this problem? 14,000. That's how much money you start with, okay? Now, this next one says 1 plus R over N. What is the rate?
6%.
Which is 0.06 divided by the number of times compounded per year. How many times is this compounded a year? What does it say? monthly, which is 12. Okay, then we take 12 times the time. How long are we looking at? 10 years. So it's just a matter of going through the problem and attaching the values. So now real quick, we're going to worry about the parentheses again, guys, because that's where we need to start. So this right here. So I want to do 0.06 divided by 12. And what is 0.06 divided by 12? 0.005. Okay, I'm also going to do 12 times 10. What is 12 times 10? 120. Good. So then, just as we did in the previous problem, I'm going to go ahead and do the 1 plus 0.005. So if I take 1 plus 0.005, I get 1.005 to the 120th. So now, this is just like the problems we've done before. I need you to calculate this first, and then take your answer times 14,000. What did we get? 25,000? 471? Point what? 5? So 50 cents? 55. Okay. So we've got confirmation here.
Okay, so if I do the YVX 120, now take that times 14,000. So hit times, and then go 14,000, not 1,400. There you go.
Okay? How are we doing on those? Okay? All right, next slide, we're going to talk about exponential decay. This is exactly like exponential growth except for one thing. What's the one thing? You subtract. Okay, so that's the only difference. So if it says that it decays, you just subtract instead of add. Same exact type of problem. Okay? So let's go ahead and look at this one. A fully inflated child's raft for a pool is losing 6.6% of its air every day. The raft originally contained 4,500 cubic inches of air. Write an equation to represent the loss of air. All right, guys, y equals what? Oops.
4,500.
Nice job. So y equals 4,500. Just a sec, let me get the purple going. There we go. Y equals 4,500, parentheses,
1 minus 0.066.
0.066 to the what power? T. Very good. So now, once again, we're going to do what's in parentheses first. So y equals 4,500 times what? Mm-mm. 0.934, very good. Because all you're doing is you're taking the whole number 1 and we're subtracting 0.066. So in the next set it said estimate the amount of air in the raft after 7 days. So where am I going to put the 7? In place of T, nice job. So 4,500 times 0.934 to the 7th power. So once again, you're going to do your power first, 0.934 to the 7th, get your answer, and then take it times 4,500. Did we get a number in the 2000s? 2,700? 90, and then what's my decimal? 0.23. My label will be cubic inches. How do I know it's cubic inches? Because I started with 4,500 cubic inches. So what do we think so far? You okay? All right, let's look at the next one. And this is where exponential decay is used quite a bit. It says the population of Campbell County, Kentucky has been decreasing at an average rate of about 0.3% each year. In 2000, its population was 88,647. Write an equation to represent the population since 2000. If the trend continues, predict the population in 2010. So my equation, can somebody tell me what I've got for y equals? 88,647.
1 minus 0.003.
Nice job. 1 minus 0.003. Okay, you caught that. It was 0.3%, so it's 0.003 to the t power. So let's simplify the parentheses. So y equals 88,647 times what? 0.997. Good job. To the t power. Okay? So then now, what am I going to plug in for t? 10. So y equals 88,647 times 0.997 to the 10th power. Okay, remember I do the 0.997 to the 10th, take it times 88,647. And what do we get? 86,023. Okay, now I have a question. Can you have 0.21 over person? No, so we'll just leave it at 86,023, and that'll be what the population is. So people would be a good label. All right, any questions? Okay, your assignment is already written on page 434. I just need you to do 4 through 13 for tomorrow.